Okay. So let me, I don't need to introduce Chandranath Chatterjee, Dr. Chandranath Chatterjee, I should say. He's a professor at IIT Kharagpur and is a well-decorated professor, actually, a lot of accolades. I have shared his bio with all of you. But so without further ado, let me hand it over to Chandranath, and I will request everybody to please mute while Chandranath is speaking so that we don't have any interference. Thank you.
Okay. Shall I start, sir?
Yes, yes.
Yeah.
And
Okay.
you have 30 minutes.
Sure, sure. So, yeah, my namaskar to all my teachers, my seniors at CAET, and all other CAETians. So, a very good evening to all of you. So, this is the 11th Tea Talk, and the topic is advances in mathematical modeling for flood risk management. So, I'll try to cover this topic without really going into the mathematics part of it. So this is the outline of the talk. So initially, I'll talk a couple of minutes on the overview of floods worldwide and in India, without really going into the statistics part of it, and what impact climate change has on these particular floods. Then I'll follow it up with what is flood risk and how to manage it. Subsequently, I'll deal with the need for mathematical modeling for flood risk management. And this, I'll follow it up with some applications, case studies of mathematical modeling for flood risk management. So these case studies will be on the Elbe River Basin in Germany, the Mahanadi River Basin in Odisha. So these two, particularly these basins, they deal with river floods. Then I'll come to Chutka Nuclear Power Plant and NTPC Kahalgaon Super Thermal Power Plant. So these two are basically infrastructure related flood risk management. And then in our own campus at IIT Kharagpur, also we have this flooding problem. So this is synonymous with urban flooding, you can say. So these applications are selected in such a way that they cover all different types of floods. And finally, I'll speak a couple of minutes on the advances in flood modeling that has taken place. So particularly with respect to the tools and techniques as well as the input data. So coming straight away to this floods, what it is, and about some details on what floods are. So if you see this animation over here, it basically deals with the global flood archives for 30 years from 1985 to 2007. It basically shows the worldwide flooding scenario all over the world. But if you focus on this area, which is South Asia, you can see that it is regularly affected by floods almost every year. And main concern is that 50% of the world's population resides in this South Asia, right? Like India and China. So if we have a look at what is the impact of climate change on floods, so this is a global picture of how climate change is going to impact floods. So let us just concentrate on these blue areas, blue and dark blue. So it simply tells that what used to be a 100-year return period flood in the 20th century will now become a 2 to 5 year return period flood in the 21st century. So that simply means that the very dangerous floods will now become or occur more frequently. So that means a third of the world's population will be subjected to the most devastating floods very frequently. So that is a cause of concern. So if you look at floods in India, I mean, let's not go into the statistics, but these figures, they show the total economic losses, the lives lost, and the people affected over the years. So for the last 50, 60 years, how it has progressed. And for all the three, you can see that there is an increasing trend, which is also a concern. Now, if you just recollect the past floods in India over the last 20 years, I mean, there are many. I just tried to list a few, but these are not all the floods that occurred over the last 20 years. So it all started with, I think, Mumbai in 2005, when we had a meter of rainfall, 1 meter of rainfall in 36 hours. So that means 1,000 millimeter of rainfall in 36 hours. I mean, you can do very little about that. Then you had these Kosi floods, 2008, Brahmaputra floods, Uttarakhand cloudburst and glacial lake outbursts, in Kashmir, Kerala floods, Uttarakhand, again a GLOF, and the Chennai floods this year. In fact, one city in Chennai this year, just 3-4 days back, again had a rainfall of 1 meter in 24 hours, 950 millimeter in 24 hours. So what really can be done about that? So this is all about the scenario. Now, when we talk of flood risk, what really is flood risk? How do we define flood risk and how do we quantify it? So flood risk, if we quantify flood risk, it is basically the product of flood hazard and the vulnerability. Now, flood hazard means the danger of flooding. So this danger of flooding is quantified by a few aspects, like the frequency of flooding, what is the depth of flooding, the duration of flooding, the flow velocities, and the rate of rise of water level. Now, if you talk of vulnerability, it is given in terms of the degree of exposure of the receptors to the hazard, the susceptibility of the receptors to the hazard, and the value of the receptors. So that means the people and the infrastructure living in the floodplains, how much exposed they are, and how susceptible they are to the flooding. And a value is given to that. So if you quantify flood risk, so this flood hazard is defined in terms of per year and vulnerability in monetary terms, INR or dollar or euro. So ultimately it becomes, say, rupees per year or dollar per year and something like that. So that's the quantification. Now, if you want to reduce the flood risk, you have to either reduce the flood hazard or you have to reduce the vulnerability. Or you can do it in combination, reduction of both flood hazard as well as vulnerability. Now, if you want to reduce the flood hazard, that means control the floods, stop them from occurring. Then you go for the structural measures like the dams, emergency storage areas, embankments or levees, and so on. So here you are basically controlling the flood, preventing the floods from occurring. Now, if you want to control the vulnerability, you go for non-structural measures like floodplain zoning, flood forecasting, and flood proofing. So floodplain zoning means nothing but you categorize the floodplains into different hazards and you regulate the activities. Flood forecasting means warning the people about the impending floods, and flood proofing is basically raising your levels of the infrastructure. So normally you have a combination of practices, both structural as well as non-structural, to address the flood risk issues. So that is about flood risk. Now, why do we need mathematical modeling for flood risk management? So mathematical modeling is basically nothing but you simulate the floods and see what could be the what-if scenarios, right? So you simulate the floods based on the rainfall, the topography, the discharge, and some fine-tuning of the model parameters, and have a look at what could be the floods that are possible. So the mathematical modeling basically provides a systematic and scientific approach to understanding, predicting, and mitigating the impact of floods. It plays a crucial role in various activities, starting from prediction and early warning systems to, say, climate change adaptation to post-flood recovery planning. So there are a variety of activities for which you use mathematical modeling. Now, once you talk of mathematical modeling, so what are its components, or really what are its requirements? So on the one side, you have models that play a part, whether it is the hydrologic or the hydraulic models, or the machine learning tools, and a GIS platform. On the other side, you have all the data aspects, whether it's the remote sensing data or the hydrometeorological data, topographic data, or structural data. When we talk of what are the advances in flood risk management, so it could be the advances in the models, or it could be the advances in the input data requirements. So I'll talk about this in the coming slides. But before that, I go over to some applications of flood risk management as case studies. So this is a study for the Elbe River Basin in Germany, and it's a hydrodynamic modeling of a polder at the Elbe River. Now, in 2002, there was a very big flood in Germany, which you can see in this remote sensing image. And due to this, around 110 lives were lost, and the damage was to the tune of 25 billion euros. Now, subsequently, several committees were formed, and they came up with this idea of potential retention sites along the Elbe. This Elbe, it flows from this Czech Republic, and it goes and drains to the North Sea. Now, if you look here, there are kind of circles here, right, all over. So these are basically the potential retention sites, or they are basically offline emergency storage areas. So if I blow up one of these emergency storage areas, it looks like this, right? So this is the river flowing, and this is the emergency storage area. When there is a very high flood in the river, these gates are opened, right? So these gates are opened, and this area is filled up. So normally this is an agricultural area where farmers cultivate the land. There is no urban area inside, and they are diked all over. This area is filled up with water. The crops are lost. So these crops are insured, and farmers get their money back. But when this is filled, the water level in the river, it goes down. It reduces a bit. So when a series of such polders are operated throughout, the water level in the river reduces substantially, so that the cities downstream, they are protected, and there is very little breach in the embankments. Now, one such polder was studied here in our study for its effectiveness through mathematical modeling using the Mike flood model. And we can see here that if this is used, this polder is used effectively, then you can reduce the water level in the river by around 20 centimeters. So likewise, if you use a series of polders, then you can effectively reduce the water level in the river. Now, yeah, slide is not moving. Yeah. Now, when you model such a polder, you have an option of whether to use a 1D model or a 2D model, or a coupled 1D, 2D model. Now, I'll not go into the details of what a 1D and a 1D, 2D model is, but simply that if you use a 1D model, you get results which are reasonably accurate, takes less time. But if you use a 2D model, you get more details. Like here you can see after the polder is emptied, so what water remains, so you can drain out the water. Now, the thing which I wanted to highlight here is that these mathematical models, particularly the coupled 1D, 2D, or the 2D models, they require a very high resolution DEM, digital elevation model. And this is the key to getting accurate results from these mathematical models. Now, if you see in developed countries, very high accurate DEMs are available. Like here, you can see sonar measurements for the Elbe River and a LiDAR DEM for the floodplains. Now, such type of DEMs are normally not easily available in our country. I mean, they are available, but it's not publicly accessible, you can say. So this is about the Elbe River. Now, if you come to the Mahanadi River, we all are aware of this, that this is the Mahanadi River basin. So there are two main structures. One is the Hirakud Dam in Sambalpur, the other is the Mundaliware in Cuttack. So they divide this into three regions, basin into three regions: the upstream catchment, green one, the middle catchment from Hirakud to Mundali, and the delta region. The delta region is basically the rice bowl of the state of Odisha. And all these rivers in the delta region are embanked with escapes like these provided throughout, so that if the water level goes up, then these are spilled over from the escapes. Now, if we take a look at the floods in this basin, now this figure shows the peak discharge or the peak floods in the Mundali, that is at the mouth of the delta. Then you can see here that there are 6 big floods. That means floods above 35,000 meter cube per second, which occurred in this particular basin. One of them was in 1982, and the rest 5 are from 2001 to 2011. Now, if you delve into what really are the causes of these big floods, so you can see here, I mean, mainly there are 3 reasons. One is a very heavy rainfall in the upstream catchment of the Hirakud, particularly at the end of the monsoon season, when the reservoir is almost full, and that makes it challenging to control that particular flood. Secondly, there is a heavy rainfall in the middle reaches of the basin, and that is the unregulated part. So this is the part so that you cannot control. And thirdly, it is release of very high flows from the irrigation dams in Chhattisgarh without informing the Hirakud authorities. So that also causes problems. Now, we also try to investigate reasons for the recent frequent high floods, which you can get the details in this particular publication. If you see here, these blue tiles, so these are basically the regions where the extreme rainfalls have been increasing, and that is the unregulated part. So this is also causing the floods to increase in this Mahanadi basin. Same for the extreme thresholds as well, right? So this is one of the reasons. So coming to like, how do you model this? Now, when you try to model this, you require a lot of data. So if you see here in this Mahanadi River basin, there are a lot of gauging sites which are shown here. And in India, this data collection is really a tedious task. I mean, it's not that in one place you get all the data, unlike in US and Europe, but you have to kind of scramble for data, go from organization to get hold of the data. And then over and above this, there are a lot of missing data as well. So you have to address these issues. So in one of the studies, we address this issues of gap filling in hydrometeorological data. And in addition, you also require a lot of remote sensing data and the weather forecast, particularly for flood forecasting. Now, a couple of studies on the Mahanadi basin that we conducted. One was regarding the flood forecasting. So here, if you see the inflow forecasting of the Hirakud reservoir, so you can see the network of base and forecasting stations. But the conventional practice is to use the unit hydrograph and the time lag approach, as well as the gauge-to-gauge correlation. These are the practices which are normally used. But recently, they have also started using this mathematical model, Mike 11. But the problem is that the forecast that they issue is only for 1 day lead time and very rarely 2 day lead time. Now, with 1 day lead time, it is very difficult to manage that reservoir. So what you need is an accurate forecast at higher lead times. So we try to exactly address this issue through the use of 2 models. And both the models used some error updating schemes using AI/ML tools. And when we use these tools, we saw that we could drastically improve the accuracy of the forecast. I don't go into the details of the AI/ML tool, but if you see here the results, now this is for 1 day forecast. So the observed values are in blue color, but these dotted lines, so these give the forecasted values. So this is quite accurate at 1 day lead time only. But when we use the AI/ML tools for error updating, so even at 5 day lead time, if you see a big flood, 30,000 meter cube per second, Even that is accurately forecasted at 5-day lead time. So if this is kind of used, it really helps in managing the reservoir properly during floods, and helps controlling the floods in the delta region. Now, in addition, you can see some of the studies like here addressed at getting a reasonably highly accurate digital elevation model. So I was talking about the digital elevation models of developed countries, but here we use these Cartosat DEM to get a reasonable representation of the topography. But here I can also say that recently the Cartosat 3 data also has been made available by NRSC. So by that, the DEM accuracy can also improve. Now, once you use this DEM and also a model, you can assess the flood hazard in the region. So here you can see this is for the delta region. So the Mike flood model was kind of calibrated and validated using the various different gauging sites. And then it was also validated using remote sensing data. So once a model is validated, so you can then use the model to simulate the floods for the different return period values. So one such hazard map is given here. So here you can see it's a flood inundation for a 50-year return period flood. So here you can see the depths of flooding and the aerial extent for the 50-year return period flood. And that is superimposed on the different land use land cover. So you can see here like what depth of flood will be impacting what kind of land cover, whether it is agriculture, urban, and so on. So, but most of the land here is basically paddy area. Now, such type of flood hazard maps are unfortunately not available for a country like India. Whereas if you see US and Europe, these are very standardized maps which are available, and they are in the process of fine-tuning them. This is about the flood hazard. Now, here we also went a step further to basically model and find out the flood hazard based optimal rice planning. Now, NRRI, that is National Rice Research Institute, they have come up with different flood resistant varieties of rice to be used for the delta region of the Mahanadi Basin as well as for delta region of Odisha. So they conducted many experiments on assessing the depth, duration, damage relationships of different rice varieties. So these experiments were conducted over a period of 10, 15 years and so, or even more. So we use these kind of data in our model to identify the rice varieties with maximum sum of average annual expected net benefit. So here, if you see, this is the optimal allocation of rice varieties. So that means in view of the floods, if you use these different rice varieties like shallow rice, medium rice, deep or submerged rice, so if you use these rice varieties at the different places, so in view of the floods, you are supposed to get the maximum net returns, right? So such type of studies can also be done through these mathematical modeling tools. So these are all about the river basin kind of floods. But if you come to infrastructure specific flood risk assessment. So this is a study on the flood hazard assessment for a nuclear power plant, which is the Cuttack nuclear power plant. So before a nuclear power plant comes up, and this is mostly done by BARC, Bhava Atomic Research Center. So this study was given to us by BARC. And before the plant comes up, they always ensure that they are safe against floods, earthquakes, and all natural or man-made disasters. So the flood aspect was given to us. So here the aim was to assess the flood hazard and to check that it is not impacted by even the rarest of rare floods. So here, the flooding can be caused by a variety of issues. So this plant site is in the Narmada Basin. So here you can see that there is a dam, and the plant site is located very near to this reservoir because the plant also requires a lot of water. So here various scenarios could occur, like various dams could breach, or there could be backwater effect, from the dam and so on, very high flows. All this was kind of modeled using the Mike flood model, and then it was seen that the plant site was in a no hazard zone. But that is fortunately so. Many times it does not so happen. So in that case, either you have to relocate the plant site or you have to have some flood proofing measures. So such type of studies, flood risk studies, are only done for these nuclear power plants. But if you see another study, which is for the Kahelgaon super thermal power plant, this study, I mean, these kind of plants, this is the flood hazard assessment for the NTPC Kahelgaon super thermal power plant. So here in this image, you can see the power plant and the fly ash dike. Now, for such power plants, no such studies of flood risk assessment are done prior to construction of the plants. So it is only after, if the plant suffers from floods, then only these studies are done. So one such a study was taken up by us. So this plant came up in 1994. And just after that, in 1995 and 1999, it was subjected to two heavy flood events. So as a result, a lot of equipment were damaged and the shutdown which occurred and so on. So this study was, I mean, the villagers who were residing nearby, they were also impacted. And there is a voice that it is only because the plant site has come up so that they were subjected to these floods. So all villagers used to come to this NTPC, and NTPC would provide them food and this for months or 2 months and so. So ultimately, a hydrological study was carried out by us to assess what really was the problem. If you see here, the floods, so here there is a 50-year and a 100-year return period flood. But the floods which occurred in 1999 and 95 were very big ones, even more than a 100-year return period flood. So it is because this particular plant was located in a very high flood hazard region. So once a plant is built up, you can't do anything about it. So what we did was, like, we suggested some flood proofing measures, and we also developed a flood forecasting system for them, so that they are warned at least 4 to 6 hours ahead of the floods, and so that they can kind of gradually shut down their plants and stop the power plant power generation. So such type of studies do also occur. Now, lastly, if you come to this so even our campus, like IIT Kharagpur, it is also subjected to this kind of a flood, unfortunately. So it's kind of an urban area flood. If you look at the DEM of this particular area, our campus, many of you are familiar with. So it is an invert saucer-shaped depression. So by looking at this, you can say that if there is a severe rainfall, there should not be any flood. It should go away to all different sides. But it does not happen. Here you can see in this figure, big rainfall events are given. So in each of these, the hourly rainfall was more than 100 millimeters. So when we kind of modeled this, we saw that in the South campus, there was a accumulation of water, and the quarters you can see here. So around 1.5 meters of water was inside the rooms. So this happened because a boundary wall came up for the campus in 2004. Prior to that, it was a barbed wire fencing, so water used to go away. But because of this boundary wall, the ponding occurs. Now, we don't construct boundary walls by carrying out a hydrological study, so it's not done. So such type of fallacies do occur in urban areas. So these are some of the kind of studies, application studies. So if you look at what really are the advances in flood modeling, so there are mainly two types. One is model-based. So if you take model-based into account, there are a lot of software which are available. But if you focus on this series of software, so this is a free one and is coming up very well with all lot of structures and things which are being put into place. So this is the software to look for the future. There are a lot of selection criteria. Let me not go into that. If you take the platforms, the Google Earth engine, which has a lot of remote sensing data, like the Sentinel, the Landsat series, MODIS and all. So you don't have to download anything. You just program things over there and extract the thematic layers. And the machine learning tools, they are also coming up in a large way. And if you look at the input side, input data side, a lot of developments in the EM, in the remote sensing data in terms of Sentinel data, and also in terms of the precipitation forecasts. So these are in a nutshell about what are all the advances. So this, I think I come to the end of my talk, but one important slide remains is that all this work that I was talking about have been, I mean, a majority of them have been done by very dedicated, hardworking, and honest CAETians with whom I had an opportunity to work with. And I mean, they were basically the workers, and I'm simply the spokesperson of them. So a big thanks to them for their true hard work. Yeah. So that's it. Thank you very much, sir.
Thank you, Chandranath. This was a great talk. I mean, something different from what we normally had before, or I should say, we are discovering new areas now, new areas right now. So, so you have a unique perspective that came up, and the best thing is that we had 31 participants, which was the highest in the last series. The 11th one was the highest, and it's the end of the year. So with that, I will open up. If you want to ask a question, you can put it on the chat, or you can just unmute yourself. But let's not have noise. Okay, one at a time, please, and give Chandranath to respond. Or if you want to discuss amongst yourselves, that's fine too. We have half an hour, and I will be monitoring the time.
Yes, sir.
So any question? Let me start with a question. Okay.
Right,
so
sir.
when you say flood and flood duration, are you talking about a peak over a threshold, or you are talking about the total volume of water in the stream?
Yeah. Actually, this duration of the flood, what I am talking about is duration in the floodplain. I mean,
Okay.
one is that it's coming in the river, but when it spills over from the river to the floodplain, so how long it stays in the floodplain? Say, for example, those rice or the paddy optimal allocation thing. So in that we required if there is a depth of water, say 60 centimeter or 80 centimeter. So how long that depth kind of stays? So if it stays longer, then more is the damage. So such sort of relationships were available for the area. So the duration is the duration of the flood in the floodplains.
Okay. And the peak that you talk about is above the stream level, stream stage.
Yes.
Maximum
Sir.
stream stage. Okay.
Right, sir.
Okay. Any other questions for?
Sir, can I ask one question? Sir,
you can.
Madam
Minister. You can.
First of all, Chandranath, congratulations for the
achievement
we already know. Actually, my question is just not a question, just as a layman's curiosity, you can say. IMD, our meteorological department, that predicts, the whatever discussions we had so far, last 30 minutes, it is all about predicting a flood, right? So my question is what they are predicting, and now you have followed certain methods and used some of the softwares. Is this the job they do, or they have some more sophisticated software or system of predicting that the entire nation depends and relies? Actually, these days we get very accurate predictions. So is there any difference, or this is what they do? I just want to know what they are doing.
Yes. So thank you, madam. Actually, yeah, what you have told is very correct, that IMD provides very accurate forecasts these days, and they also update it from time to time. So they do it in two modes. One is that they provide 5-day forecasts, that is 1 day, 2 day, 3 day, 4 day, 5 days. So those forecasts are mainly for agricultural purposes for the farmers, that whether they should irrigate or not. But in addition to that, they also provide forecasts for the extreme precipitations. Like nowadays we get, like say last week, they told that Chennai will get heavy to very heavy rainfall. Sometimes they also quantify it, that this will be the rainfall, 200 mm, 250 mm. And they do it through numerical weather prediction models. And that's a very standard procedure that they follow. And they have really upgraded their systems to provide quite accurate forecasts, even pinpointing. But what they do is basically the rainfall forecasts. They don't translate it to floods. I mean, suppose they tell that in Chennai, there will be a 200 millimeter rainfall. So does not mean, I mean, it does not say that whether my house will be impacted or not, or a given locality will be impacted or not by the floods. So the translation of that rainfall to floods is what I was talking about.
That means to the common man that is not getting translated.
Yes,
isn't it?
yes.
Okay,
So my
okay.
neighborhood will have, say, this much depth of water. So those kind of information also needs, I mean, from a user point of view, simply, I mean, knowing that Chennai will have 200 millimeter of rainfall, I mean, does not provide me some concrete specific information. Rather, if I get an information like, okay, tomorrow my locality will have a flooding depth of, say, 1 meter. So then I can take some measures, like I can say move my furniture to second floor. I can move away from my house to another place and so on. So some corrective measures I can take. So that is basically the
difference.
flood part, the difference. Yes, ma'am.
Okay, thank you, thank you.
By the way, I just wanted to make a disclaimer here, because I have now heard from two people. One is Dora Babu before the talk started, and now Kalpana. Both of you said that we are not in a different area. We are all agricultural engineers. Okay, I mean we need to really focus on our undergraduate study, where we have actually gone through the breadth of the courses. Okay, after that you have specialized. Okay, so that doesn't mean that you are forgetting your root. So when you say that I am in milk production, or I am in something else, food technology or whatever it is, still my point is that you are basically an agricultural engineer, and I'm really proud of Chandranath, because he has trained so many CAETians, including Bhabagrai. I saw Bhabagai's name. So he was your student. I didn't know that. Anyway,
Bhabagrai was my first master student.
Your first master student. Okay. There is a question from Sudhanshu Panda, and Sudhanshu, you can unmute and ask. You don't have to put it on
I
the
think
chat.
some chat messages I'm getting from sir.
Yeah, but Sudhanshu's is, do we use snow melt data in flood modeling? Now, faster snow melt is causing flood in India frequently and elsewhere. In US, FEMA developed a model called HAZDAS-MH model that works with HEC GeoRAS to find the flooding impact after a dam floodgate opens, or God forbids a dam breaches. It takes into consideration of river profile. So that's the question is, do we use snow melt data in flood model?
Right, right. So as like he has pointed out, he's very rightly pointed out that snow melt and fast snow melt, that is also really causing the trouble. I mean, I myself personally, or in my group, we have not used, because most of our studies pertain to this Mahanadi Basin, where the snow melt component is not there. But yes, he has a very valid point, because all our Himalayan river basins, for that nowadays this component is very important. And as I also told, this HEC series of models is really getting upgraded. Like in our group, we used the Mike models earlier, because earlier HEC did not have so many options for modeling floods, particularly on the structure side and all. So we used to resort to these Mike models. But these Mike models, though they are really good, and they have got a very good support also, but the prices are too high. I mean, if you buy it for once, it is fine, but every year you have to provide a huge amount of money for upgradation and all. So it does not become sustainable. But if you see this HEC model, the way it is coming up, I mean, people like in India, they are switching to these HEC models. But the only concern here is that the support still is not very good. I mean, if you encounter problems and if you write to them, I mean, there are the responses are not that fast or something like that. I mean, in days to come, this will also be addressed, I'm sure. But it is a package which is growing very fast. I mean, people in India are also using this, have started using this and converting their platforms to these HEC series of models. Yes.
Yes, sir. Yeah, actually, HEC GeoRAS, sir, this is Sudhanshu Panda. HEC GeoRAS is really have a user group. You don't need to ask developers. You can put the question in HEC GeoRAS. They can answer you. They will be everywhere. And you know very well, smart people always give advice freely. So they don't ask for money. So it would be done very well. And HEC GeoRAS is kind of your civil engineering type calculation-based model because it uses your river profile. Just now you explained how in Germany they actually have 2 or 3 areas where they can divert the water and water will be staying there. So the river profile will go down and the flooding downstream will be much less. So this one actually calculates exactly where, how much flooding will happen. And that maybe talk to your students, they may explore, even if it is US-based thing, Hazus MH multi-hazard model. So it has one huge component related to flooding. And it's kind of a black box type thing, but I can explain that. I can hook you up with the developers here in Atlanta. So they can help you how to modify that to India-centric. And that major advantage of this one is it has another like aspect of it. After flooding, how many people, how much infrastructure will be damaged. So it can even calculate the total amount of debris. But in US has everything like numerically created as a database, like building size, building how much materials used in building. So if we can bring those, how many people we have, people sensors and all this, so that are brought into consideration. But one huge aspect of it, like it can tell you where you can move your people during morass, like during this kind of situation happen. These are the locations like school or church, they are in the upper ground. These are the roads. You can use advanced GIS stuff. We use network analyst modeling. So that way you can design a evacuation route. So that's a complete kind of flood potential mapping, modeling, and at the end, evacuation and shelter and all this. So maybe try that with your group. You have a huge group.
Thank you. Thank you very much. Actually, I'll also get in touch with you. In fact, my group and some other groups are also converting their platforms to these HEC series.
Yeah,
so
please, sir.
It will be great to get in touch with you and collaborate to set up our models. I mean, these Hazus MH I am also not aware of. So it will be good to know these models and the developments and to get in touch with you so as to address the other issues will be really great. Yeah. Thank you very much. Thank you very much.
Sure. Thank you. Thank you, sir.
Any other questions for Chandra? Who wants to ask? I heard a voice. It's okay. You don't have to be shy.
Pandey?
Yeah, Pandey wants to ask.
Yeah.
Oh, okay, go ahead. Pandey, go ahead.
नहीं मेरा क्वेश्चन नहीं है कुछ भी.
Oh, okay. I thought you were asking a question.
I can jump in.
Yeah, go ahead, Priyabrat. Yes.
Priyabrat.
Our MIT guy. Yes.
Congratulations, sir, for your nice fellowship.
Priyabrat. Yeah, thank you. Thank you very much.
Yeah. So your model is at this point predicting so well. So I'm curious that how this AI and ML will again improve it further.
Yeah, that's a good question. Actually, you see, the flood forecasting study that I showed, in fact, use these AI/ML tools to improve the forecasts. So if you see, I mean, nowadays, Google, they have already started collaborating with Central Water Commission India, and they are providing flood inundation maps. So if you see this Google, what you call street-based search, when you do, like when you search, if I have to go from one place to another, you get a network, a road network to reach there. So during the monsoon season, it also shows a flood layer. So it shows you the alternate routes that you may take in the event of a flood. So it shows you that these kind of routes are likely to be flooded maybe in the next 6 to 8 hours. And instead of that, you take this sort of a route. So Google is basically using AI/ML tools, using the data of Central Water Commission to forecast the inundations. Now, Central Water Commission also does not forecast inundations. It forecasts only the water level in the rivers. So again, the water level in the rivers, if you forecast, they are not of much use to the user. I mean, if water level in the Mahanadi will reach so and so, so I don't know how much I am impacted. But if you forecast the inundations, then you are telling the user that, okay, your area will be kind of flooded or to such and such depth and so on. And that is what Google is exactly doing. I mean, they have started issuing forecasts, I think from 2021 or 20, I'm not sure. But last 2-3 years, they have already started collaborating. And what they are doing is now for the Brahmaputra, I mean, three or four states, Assam, Bihar, then I think a couple of other states which are more prone to floods. So they are forecasting the inundations. So these AI/ML tools for forecasting, I mean, they have now started become operational, being used in operational mode. So these are the ones which when used, and sometimes they are being used in conjunction with the physically based models to improve the forecasts. Yeah.
Thank you, sir.
I was asking any follow-up, Priyabrat? Sorry. Okay.
No.
There is another question from Sudhanshu.
Yeah.
He's asking.
Sir, I have one more question.
Okay.
This is Sudhanshu again.
Yeah.
This is for my own help. You just explained how you are using the NRSS Cartosat imagery to create 1 meter DEM. But can I get help from someone to get the Cartosat and how to create 1 meter DEM out of it?
Yeah. Actually, this what Cartosat study which I showed was for a 30-meter DEM. It is not a 1 meter DEM. Sorry, not 30 meter. It's 10-meter DEM. Because it was the other version, I mean, the previous version of Cartosat which was used. Now, currently, NRSC is providing Cartosat DEM with very fine resolution data. So if that data is used, then we can develop this 1 meter DEM. But our experience with Cartosat data is that if you simply use their these ground control points, the DEM that you get is not really, I mean, the accuracy is not really improved. But if you carry out your own survey in that area and develop those ground control points, then you can improve the DEM. So currently we don't have this 1 meter DEM of Cartosat. We are using this 10-meter DEM. And that 10-meter DEM, when we use for Cartosat, we saw that the river cross sections are improving. But if you look at the floodplain, they are not, I mean, that much different from the SRTM, those 10-meter DEM.
No, sir, I will email you. Maybe if you know someone, because my friends at NRSA are all retired. So, so you may be knowing someone that can help. Actually, we are working on a landslide modeling in Himachal Pradesh with IIT Guwahati. So we need really high resolution DEM per se. So if that
Right.
helps, that would be really useful for this
Right.
research.
Yeah,
I'll
yeah.
email you.
Sure. I'll get in touch. But that actually, I also pointed out in my slides that getting a high resolution DEM in India is a real tough thing. I mean, there are of course companies which will survey and give you the LIDAR data, but the LIDAR data to process that, I mean, that also requires a lot of expertise, which I mean, our group at least does not have. But you
No,
don't
sir.
have
We are working with GDI now. NASA has sent a satellite GDI. So this one is the LiDAR satellite. So it is selectively flying.
Right.
So if I got lucky to get data for the study area we are using, then I will let you know how we are downloading data and making it one like high resolution imagery. Like it would be around 15 to 30 centimeter DEM.
Yeah.
If we succeed, we are working on it now. So once it's done, then may not need Cartosat, but
Right.
still help with Cartosat is needed. So thank you
Sure.
for just a new.
Yeah. Anytime you send a mail, I mean, whatever resources I have and whatever help I can provide right now, I mean, I can provide. Yeah. Thank you very much.
Thank you so much, sir. Thank you so much.
All right. Any other questions for him? So, yeah, Priyabrata actually asked a good question. When you are when the model is predicting so well, why to use AI ML to do anything? And AI ML can actually sometimes screw up the model results. Okay, I mean it depends on what kind of. Pandey, can you mute? Pandey, can you mute? Okay. So basically, it can also screw up depending on the type of AI ML model you're using. And of course, I saw that you use some wavelet restructuring of the model. Okay. Even with wavelets, what wavelengths are you eliminating and what wavelengths you are retaining? That also is a tricky thing, right? So, but the thing is, one good thing I liked about, and this is a comment, not a question really. One good thing I liked that you had that duration of inundating paddy fields and how to get the maximum output from those paddy fields, based on the duration of inundation. Okay. I think more such work should be done, with flood risk. I mean, as agricultural engineers, we are more interested in crop security or food security, right? I mean, we can work on preventing a disaster in a nuclear power plant or a thermal power plant. That's okay. But again, the thermal power plant that you mentioned, was it near a stream? I didn't see any.
Right, sir. It was near the main Ganga river.
Acha. Okay. So basically, when we are flooding fields, let us say we decide to flood fields, okay, or naturally sometimes we get those flooded. Then these kind of analysis, again, like what kind of crop can be resilient to those increased climatic, increased duration of flooding or whatever it is. Well, yeah, increased duration of flooding, right? That's the right word. That's very important. So have you thought through how you can, I mean, other than rice, are there other crops or anything that you are trying to engage with so that we can attain food security?
Yeah, sir. Very nice and pertinent question that you have asked, sir. So actually, earlier when I was in National Institute of Hydrology and I was posted in Patna, their regional center for some time. So I saw in northern Bihar, I mean, where the fields are, I mean, in the monsoon season, they are invariably flooded. And if you go to those flooded fields, I mean, after the flood has receded, but still the field is waterlogged. So they call it chores, something like that in local terms. So when I saw there, I mean, they have a very peculiar rice variety. So where if the depth of water increased, so the rice panicle, I mean the portion which is above water, so the height also kind of increases. I don't know what kind of a variety is that, but that way, I mean, they used to get the yield in spite of the floods year after year. So if such kind of varieties, I mean, what they are doing is, of course, they have a lot of experience, I mean, of the areas which are flooded, and they take up those varieties. But if such varieties are researched on and a scientific study is made to know what actual areas should be put under such varieties, I mean, it will be really helpful for food security and all. I mean, similarly in other places as well. So your question, that is very pertinent in view of the fact that you see every year we are having floods, whether it is in the urban area or in the rural settings. So how to increase this food security in spite of these floods is a, I mean, big challenge. So we should, definitely think about this aspect.
Dr. Jenna is saying that the name of the floating rice variety is
Hansewari.
Hansewari. Thank you, Dr. Jenna. Okay.
Yeah.
The other thing, well, is there anybody else to ask, or can I ask one more question here? Not a question, sorry. Sudhanshu brought up a very pertinent point. Like, we are not only talking about Odisha, for example, but there are areas of snow melt and rapid snow melt. How to incorporate that into the model. And he said that there is already models developed, but we are interested in the data. Now, data collection from snow melt is difficult. I know, because I live in an area where there is all snow all around me. Because the latent heat of snow melt, the processes, the latent heat transfer, and the sensible heat transfer, it's difficult task to really determine. But what we can determine is the volume of water. If there is a snow amount of snow with a bulk density, then we can determine what is the volume of water that it will produce after the melt. So if something like that, Sudhanshu is showing something, but if something like that is of interest, then we can talk about it later, and see if we can incorporate some of it. Okay.
Yeah, right. The snow melt studies, right, sir. They are becoming very relevant nowadays, particularly in our Himalayan regions where we are getting these glacial lake outbursts. So it is a real concern. I mean, to address those challenges.
No. Glacial lake outbursts is different. I'm talking. What he was talking about is pure snow melt. Okay.
Snow melt,
if there is snowfall instead of rainfall, then what is the melt? That is going. So a glacial outburst is a completely different animal. That's a hazard mitigation or a hazard issue. Okay. Anyway, so please ask your team to join this conference.
Thereby, on the snow melt thing, actually, I have a model already developed for Yellowstone National Park and got really 85 to 90% accuracy, 87% accuracy. So we have the snow melt algorithm used there, and for US, we have the snow melt database already, just like the precipitation hydrology, like water database. So we do have, and I'll send you the link where to download the thickness and everything, and we have the algorithm to modify the snow to water and their flow and all this. So they are there. So I'll send you the presentation. AGU conference last year, I presented that, and I'll share with also whoever are interested. With Sir also, I'll share that. It is there.
Sudhanshu, why don't you give a talk on November on some of this? Okay, we have a slot open in November for T-Talk. Should I?
Sure.
Should I? Okay, I'll put you down. All right, we are almost out of time. Let me first congratulate Chandranath.
One more request. This is the opportunity for me to say, I wrote in the chat box, there is a conference, RCRM conference that's happening, River Management Conference. That's generally happen every year through IIT Guwahati and IIT Jammu. They do it, and it's a very well international conference. And maybe SAR's team because they are working exactly in the same area.
Yeah.
They may have already attended. If not, sir, please attend that one. That would be in
Sure.
March 9 and 10, I guess.
Okay, sure.
It's a very productive conference. Dr. Datta, you might be knowing.
Yeah, I know him. Yeah, I know him very well. Yeah.
Yeah, and Dr. Chemblu. So they are the main part of this conference. Sir.
Okay,
Sure.
so there is one last question. I'll allow it because we started slightly late also. Emergency reservoir system is vaguely adopted in Cuttack city by JICA. This is from Ramakrishna Das. But what can we do in hilly areas where cloud burst happens?
Yeah.
Do you have answers, Chandra?
Yeah, actually, I have not worked in very hilly areas, but that's a real challenge. I mean, if cloudburst happens in hilly areas, the real challenge is that the travel time is very less. And even if you are providing a forecast, that lead time will be maybe half an hour or 1 hour, where, I mean, that will not be transmitted to the people also. So it's a real challenge if you have something in the hilly area. So you have to basically forecast the events itself. I mean, the rainfall events that accurately, if you can do, then only it can help. Otherwise, if a cloudburst already has occurred, then it's really difficult. But personally, I mean, our group has not worked on this, so I can't really comment on this particular aspect. Yeah.
Okay, thank you. Let me say this much. We're proud of all our CATians, especially Chandranath for his NAS scholarship and giving a wonderful presentation today. NAS fellowship, I shouldn't say scholarship, NAS fellowship, and all his accomplishments. We're very proud of you, Chandranath. You know, on behalf of all CATians, thank you very much for the talk today, and hopefully we'll join in the future for our tea talks so that we can make it more vibrant. Okay.
Yeah. Sir, thank you for this great initiative of this tea talk. I mean, it's a wonderful initiative where we are hearing so many CATians doing so much good work. And thank you for providing me an opportunity to give a talk here. Thank you very much, sir.
Thank you. Thank you. Have a good rest of the day, evening.
Okay.
Yes.
Thank you, everybody. Thank you, my students, and I am proud of all of you. I am proud of Chandranath Chatterjee for a nice presentation. Thank you all.
Thank you, sir. Thank you, sir. Namaskar.